Okay, 4.2, writing equations in point-slope form. So by now we should have already been done writing equations in slope-intercept form. Point-slope form is just another way to write a linear equation. It's actually this form we get from, oops, go back here. This form we actually get from the equation m equals y2 minus y1 over x2 minus x1. So we end up moving or manipulating our slope formula. Remember, this helps you to find a slope given 2 points. We end up manipulating this formula by multiplying out the denominator here. So it becomes m times x2 minus x1 equals y2 minus y1. And we think, well, we only have 1 point. We'll call that x1, y1. And a slope, which is m, why we call it point-slope form. So what we'll do is we'll get rid of the 2's here, and we'll rewrite it so that y is on the right-hand side. And then that is point-slope form. Okay, so point-slope is that form right there. It's a way for us to write an equation if we know a point and the slope. All right. So I usually tell students, look, if you know a slope and the y-intercept, use slope-intercept form. If you know a point and a slope, use point-slope form. You can always change point-slope form into slope-intercept form. It's easy to do. In fact, the point-slope form looks a little messy when you're done with it, but it's just another way of looking at a linear equation. So let's try one. Write an equation in point-slope form of a line that passes through the point 12, negative 8, and has a slope of 1/3. So you need two things. You need slope and you need a point. Okay. So our slope here, our slope is actually 1/3, and our point is the ordered pair 12, negative 8. And that point is our x1, y1. And so just writing out our form, y minus y1 equals m times x minus x1. And substituting the values in, that's just y minus negative 8 equals m, which is 1/3, times x minus 12. Now be careful when you have these double negatives. Anytime you have that negative, that's going to give you a plus right there. So it's really important that you substitute things into formulas using parentheses. Now, saying that, I forgot to use parentheses there to show that I substituted in for m, and I forgot to use parentheses here showing that I substituted that 12 for x1. Though in those two cases, the parentheses don't change anything. However, in this case, with the y minus negative 8, it did change something and made that a plus 8. So I'm going to end up dropping those parentheses because they don't change anything. And if we want to go, well, first of all, if we want to stop and write our equation in point-slope form, like they've asked, this is your equation in point-slope form. Let me get rid of my eraser here. All right. So there is point-slope form. Now, if it said to write it in slope-intercept form, we'd have a couple steps, and I'll show you that on another problem here. All right. Well, let's go ahead and write an equation of a line given 2 points. Remember, in order to write an equation in point-slope form, you need to know m, and you need to know a point. All right. So this one says write an equation in slope-intercept form of a line that passes through this point and this point. So note, they don't give you m here. They give you 2 points, and it really doesn't matter which point you use, but they don't give you m. So in order to find m, you have to use your slope formula. y2 minus y1 over x2 minus x1. Okay, so that's going to give me those 4 pieces that I need to deal with. And I'm just going to label x1, y1, x2, y2, and I'm going to label it that just because, look, this is my first point that they give me and my second point. You could have labeled it the other way, it doesn't matter. Okay, so when I do this, I get -2 and 5 and 4 and 1. Okay, so that ends up, let me just keep working down here, -6 over 4, which can reduce to -3 over 2. So that is our slope, -3/2. Now I could write the equation with either point, so I'm going to actually write it with both points here. Okay, and I'm going to use point-slope form because they tell me I have 2 points and I have m now. So if I go y minus y1 equals m times x minus x1, well, if I use 4, 1, so y minus 4 equals our slope, -3/2, and then x minus 1. Once again, notice you really should use parentheses to input. I didn't because it doesn't change the value in this one, and it makes it look really cumbersome with all these extra parentheses. Okay, but we get y minus 4 equals -3/2 and x minus 1. And then it says slope-intercept form, so I actually have to multiply this out. So to get from point-slope form, which I was in right here, this is point-slope. To get to that, from that to slope-intercept form, I've got to keep going. So -3/2 x minus 3/2. Ooh, that's kind of an ugly number. Okay, and then we'll add 4 to both sides, so we get y equals -3/2 x. And then when we add 4, like 3/2 is like -1.5 if you think of it that way. And we add 4 to that, so that's going to give me +2.5. Okay, so if you want, you could rewrite this as 1.5, which some students like a little better. You could do that if it's a terminating decimal. Okay, it doesn't repeat. All right, that is slope-intercept form, and that's what they're asking for. Remember M and B there. All right. Now, just to show you can do it the other way, if you were to take y minus y1 equals m times x minus x1, and you were to switch these around and say, okay, this is going to be switched around. We're going to call this one, we're going to call this one 2, and this one 1. At that point, you go y minus -2 equals -3/2 times x minus 5. And this double negative gives you a positive, so it's y plus 2 equals -3/2 times x minus 5. We distribute, where this is our point slope right here. We distribute, we get y plus 2 equals -3/2 x, and negative times negative is positive, and that's 15/2. And since we're going to be moving this 2 over, it might be nice to think of 15/2 as a decimal since it terminates. So that's also known as 7.5. So subtract 2 from both sides, you get y equals -3/2 x, and then plus 5.5 when you subtract that 2. Okay? Slope-intercept form. And what we should look at is the 2 should match up. It doesn't matter which one you use. So when I look here, hey, -3/2 x plus 5.5, this should read -3/2 x plus, 2.5. That means we made a mistake somewhere. And normally the mistake is made, the common mistake is usually bringing in a negative. So I'm going to look back here and make sure I multiplied right. negative 3 halves times x, negative 3 halves x. Negative 3 halves times negative 1 is oops, this should have been a plus. Oh boy. All right, so hopefully you caught that when I was working through it. That's a plus, so that means I add 4 over. This actually would have been 4. When we add 4 to 1.5, it should have been 5.5. All right, there we go. Now they match up. We're good to go. Hopefully you guys caught that when I did it. I didn't do that on purpose, but that is a common mistake, bringing in a negative. So anytime you bring in a negative, always focus if it's a negative times a negative. That's a good lesson learned there, hopefully. Okay, let's go ahead and try another one here. Write an equation in point-slope form. Remember, we need a point, and we need the slope. Hopefully that's becoming redundant and really boring to you, so that would mean you know it. If we're writing a linear function with these values, just remember when we see something in this form, this is your input, this is your output. Okay? And so thinking of it that way, input, remember, stands for x, output stands for y. So in other words, negative 2 is our x, and 4 is our y. So you're just giving a point there. And same thing here, you're given a point, 4, 8. So really what it's saying, write a linear function given these 2 points. Once again, you need to be able to write, or you need to be able to find the slope first. So use your slope formula. y2 minus y1 over x2 minus x1. Okay, so our 4 kind of seats there that we have to deal with. Well, if I call this x1 and y1, x2 and y2, well, that would be 8 over 4 and 4 over negative 2. Okay, and doing the math here, 8 minus 4, that gives me 4. And 4 minus negative 2, there's that double negative again. Double negative makes a positive, so that's 4 plus 2, or 6. That equals 2/3. And so now we'll use our slope and our point in our point-slope form. So y minus y1 is equal to m times x minus x1. Okay, so we have y minus y1, which is 4, equals m, which we know now is 2/3, times x minus x1, and x1 happens to be negative 2. Okay, so we get that double negative right there, which makes a plus. So we get y minus 4 is equal to 2/3 x plus 2. Okay, right now that's point-slope form. So if we need to leave it in point-slope form, there we've got it. Okay. If we're going to change it to slope-intercept form, we're going to distribute that 2/3. So we get y minus 4 is equal to 2/3 x, and 2 2/3, or 2/3 times 2 is 4/3, so plus 4/3. And then we're going to move that 4 over by adding 4 to both sides, so we get y. So I'll move that over there. So we got plus 4 here, right? So we end up with y is equal to 2/3 x. And then 4 in terms of thirds, if you think of that, 4 times 3 is 12. So we could write 4 as 12/3. And that gives us 4/3 and 12/3 rather than 4/3 plus 4. So 4/3 and 12/3 is 16/3. Okay, that's slope-intercept form. And then we should write it as a function because it says a function f, so we'll write that as f of x. We'll replace y with f of x. And that's equal to 2/3 x plus 16/3. And now we have our function. Okay. Just make sure that you go from slope-intercept form, write it as f of x. That way you have a function f. So, okay. All right, just one other little piece here, determining if it is possible to write a linear model for a given set of data. If it's possible, write the model. If not, explain why. Well, First, remember, in order for data to be linear, it has to have a constant rate of change. And looking at this, when we ask our question, does it have a constant rate of change? Looking at it, we go, okay, well, I go from 1 to 4, that's going up 3. I go from 4 to 6, that's going up 2. And I go from 6 to 5, that's going, or 6 to 11, that's going up 5. And looking here, I'm going from 5 to 26, that's going up 21. I'm going from 26 to 40, that's going up 14. And then I'm going from 40 to 30 or 75, that's going up 35. Now, on the initial look, you're like, whoa, the x isn't even increasing by the same amount. So no, it's not linear. Well, remember, constant rate of change, that means your change in y over change in x is constant. Okay? What that means is you're comparing these things. So if I was to say, when I go up 21 on x and go up 3 on y, is that the same? So kind of like a question mark there. Is that the same as going up by 14 on y and 2 on x? And is that the same as going up 35 on y and 5 on x? And the answer is, yeah, they are the same. They are the same because they all reduce to 7. All three of those fractions, or those slopes, reduce to 7. So yes, you can write a linear model, okay? They all reduce to 7, okay? So if it is possible, let's write the model. Well, in order to write an equation, we need to know a couple things. We need to know m and a point, or we need to know m and b. So if we think of it this way, if we want to write it in point slope form, we need to know the point and the slope, okay? And just because of my type A-ness, we need to know a point and we need to know m. Those are the two things we need. If we want to write it in slope intercept form, we need to know the slope and the y-intercept. So we have two ways we can write it. Now, note that in both forms, you need to know the slope. I mean, that's something you just need, and we have the slope. The slope here is 7. So that's good. And we have a ton of points. Okay, so you could just quickly write an equation, just pick any of those points. I'm going to pick maybe this one and this one. Okay, y1 and x1. So I could just say, well, that's just y minus 5 equals 7 times x minus 1. That's how quickly it should go. Okay, y minus y1 equals m times x minus x1. And I could have used any of these points. And I know the equation will look different, but if I change it to slope-intercept form, no matter what point I use, I would end up with the exact same thing. Okay, add 5 to both sides, you end up with 7x minus 2. All right, so you can go from point-slope form to slope-intercept form. Now, some of you would look at that and go, why would you even do that when you could just kind of work your table backwards? I know my y-intercept is when x is 0. And I know if I changed, you know, if I know my slope is 7, that means as I go up by 1, I would go up by 7, which means this would have to be a negative. You could do it that way as well. All right, that's all I got for you. Good lucky.